In the next few lessons, we are going to see how to create a digital oscillator. Let's open back up Atom and head back into our code. Back at basic saw wavegen.c, we're going to take a look at this function right here, y equals waveCompute f0. This is where we will create samples of the base waveform oscillator. For now, we are going to do a raw oscillator sample, meaning there will be no additional processing such as modulations or filtering. To see what the waveCompute function does, go to Source, Oscillators. Scrolling down, we find waveCompute. This function is passing the frequency we requested the oscillator to perform. Inside waveCompute, we see two more functions: offset frequency at op1 frequency, y equals 0.8f times basic saw at op1. And finally, we have a return y, which will return the value we obtained from basic saw. Please notice the variable op1. We call this operator 1, and please note it is the address of op1 that we are passing. Op1 is a struct type variable as seen at the top of oscillator C. We see op1 defined as oscillator type op1. Oscillator type, or oscillator underscore T, is a struct type defined in oscillators.h, which is a header file. Let's take a look at it. It's going to be over here under include oscillators H. Inside oscillators H, we find the oscillator type struct. When we say oscillator type op1, we are creating a variable named op1 that is a type def of oscillator T, which we see above. We can name more variables using the same type def to create more oscillator T structs. We can have op1, op2, op3, and they will all use the same template defined above. The address of op1 is the memory address at the beginning of the named struct. We have members inside the struct I like to refer to as parameters, and we will use these parameters to keep track of many values stored in each oscillator as we process them every time we go through the for loop in make sound. The oscillator T struct type has many parameters we will not use for most oscillators. The extras are simply unused until we create an oscillator that utilizes them. Later in the lesson, we will see our first example of an oscillator called basic saw. Try not to confuse oscillator T structs, such as op1, op2, as the oscillator. The struct is simply used to keep track of values used for that oscillator. For most of our oscillators, we will only be using amp, frequency, phase, and out. Please note that all these parameters are float type values. Heading back to oscillators.c, we see this function, os_init. And inside the function, we see most of the parameters we saw in the oscillator type struct. Os_init has three arguments passed: op, amp, and frequency. The first argument, op, is going to point to the address of that oscillator struct. So if we want to use op1, we will call the function like this: os_init at op1 0.8f 587.f, which translates as pointer to the address of op1, 0.8f for amp, and 587.f for frequency in hertz. We use the f in 0.8f and 587.f to indicate we are using a float value type. So looking again at the os_init function, we can see for each parameter we have something like this. Op amp equals amp. What we are doing is dereferencing the member of the struct op1, which is amp, and placing a value in there, which is the argument from the os_init function amp. The two amp variables look like they have the same name, but they are not the same variable. You treat op amp as a complete variable name. The local variable amp is only used inside the os_init function. Let's use the example function called os_init at address of op1 0.8f 587.f again. Op amp equals amp will be operated as op1 amp equals 0.8f. Op last amp will also be operated as op1 last amp equals 0.8f. Op frequency equals frequency will be operated as op1 frequency equals 587f. We can actually see our example function call in wavegen.c at the synth init function. Now this value here, 587f, is simply a random value I used. You could place just about any audible frequency value you'd like in there because you're going to change it in the make sound function to a new value of your choice. And later on, when we get the MIDI interface working, the value will change for each key we play. Now what synth init does is it will initialize our op1 oscillator struct so that it's ready for use when we need it. Synth init was already called when we powered on the microcontroller and it ran main void. We can find that in main.c main void synth init. So there is no need to call it again. If we didn't initialize the parameters in the op1 struct, we would not have any amplitude or frequency values to render an oscillator waveform with. And if we didn't hard set some of the parameters to 0, we could also end up with random values instead of 0, possibly creating undesirable outcomes. Going back to waveCompute, you can see that we define a variable y as a float value. Again, this is a local variable. Next we have a function called offset frequency. And again, this is passing on the address of op1 and the frequency that was passed when we called the function, which is back over here in make sound under y equals waveCompute f0. And f0 is 200. Now offset frequency is here near the top of oscillator.c. You can see the function right here. We have two arguments. One is a pointer and the other is a local variable. And what this function simply does is if we are pointing to op1 and we set a frequency value of 200, then we are going to see something like op1 frequency equals 200. And the value 200 gets stored into the frequency member of the op1 struct. Now that we have our op1 oscillator initialized and set the frequency, we are ready to do a function call that will process a sample. That function call in waveCompute is y equals 0.8f times basic saw address of op1. But before we take a look at this oscillator function, in the next lesson, we're going to go over some basics of the waveforms we'll be using and how we'll be using them in our code. Specifically, how they will be used in the basic saw function.